Everyone, this is Navneet. It's a small presentation regarding machine learning. Machine learning deals with the huge data sets, and it collects the previous data from the customers and generate the future data to the customers. And where every company is trying to switch it to the machine learning. Machine learning deals with some mathematical algorithms, some proofs and theorems, and it generates its own algorithms. And machine learning is used in web search, spam filters, and fraud detection and stock trading. And there are many types of machine learnings, and I will focus on the classification, which is which is one of the most mature and widely used one. First problem we are facing in machine learning is learning, where there are thousands of algorithms for learning, and yet hundreds more are published each year. The key not to get into lost is this huge space is to realize that it consists of combination of just three components. The three components are more important in machine learning. The first for learning the data. Since we are providing the algorithms based on the previous data, so we need to learn the data, how it is organized, and what are the keywords, and what are the key elements that are useful for predicting the future data. And representation, the three components are representation, and evolution, and optimization. The first one, representation. A classifier must be represented in some formal language that the computer can handle. So the computer should have some formal language that is nothing but just defining the classifier. So representation is nothing but is choosing a set of classifiers that it can possibly learn. The set is called the hypothesis space of the learner. If a classifier is not in the hypothesis space, it cannot be learned. And the other component is the evolution. Evolution is the function also called objective function or scoring function. It is needed to distinguish a good classifier and the bad classifier. It's just a scoring function, where it distinguishes between where it shows the difference between the good classifiers and the bad classifiers. And the third component is the optimization. Finally, we need a method to search among the classifiers in the language of the highest scoring one. The choose of optimization technique is the key to the efficiency of the learner, and also helps determining the classifier produced if the evaluation function has more than one optimum. To find the highest scoring function. And decision surface is a surface which divides the classifiers from one from to the other. For example, if these are all categorized as one classifier, and these are all classified as one classifier, where the decision surface is this line which separating one from the other. If we get another item, which may be here, so it can be possibly the decision surface, this red decision surface. So it is what the classifier is. There is a decision surface which divides the classifiers from one classifier from the other. And general issues of supervised learning algorithm. This is the flow chart diagram. And inductive machine learning is the process of learning a set of rules from instances, creating like classifier that can be used generally from new instances. The process of applying supervised machine learning to a real world problem is described in this flowchart. And the first is the problem which the machine learning is facing, and the second is the identification of required data. We need to identify the required data which is necessary for this problem. And data pre-processing or data presentation is the next step, followed by the identification of required data, where in this process we are going to find the key elements or key classifiers which are related to this problem. And it goes to the definition of training set, where the training set is we are going to find some we are going to collect some huge data sets, and which are we are going to predict the classifiers, and we are going to select an algorithm in this section, algorithm selection, and we are going to check the algorithm with the training set, and we are going to evaluate with the test set, and if it is yes, then this is the classifier we are looking for. If not, we need to go to the parameter tuning, where we need to provide some additional information for again training. And otherwise we have everything we need to go and check for the identification of required data or data pre-processing or definition of training, and we need to set for an appropriate algorithm if we do not find a good classifier. And in the above flowchart, algorithm selection is the important task in the learning concept. We got three techniques for which which are used to calculate the classifier accuracy. One technique is to split the training set into two-third, and the other one third for estimating the performance, and the other one third for the estimating the performance. Another techniques known as the other one is known as cross validation. The training set is divided into mutually exclusive and equal sized subset, and for each subset the classifier is trained on the union of all the other subsets, which means that they are divided such that the data should not depend one on each other. That is what mutual exclusion is. And the third one is leave one out. Validation is a special case of cross validation. All test subset consists of a single instance. This type of validation is of course more expensive and computational, but useful when the most accurate estimate of classifier's error rate is required. Decision trees. Decision trees are the hierarchical structure of nodes and the branches. Classify instances by sorting them based on future value. Each node is a decision. In each node in a decision tree represents a future in an instance to be classified, and each branch represents a value that the node can assume. Instances are classified starting at the root node and sorted based on their future values. And this is the hierarchy structure of a decision tree, where these 81 or 81, 82, 83 and 84 are the nodes, and A1, B1, C1 and A2, B2, C2 and A3, B3 and A4, B4 are the branches, where yes and no are the leaf nodes of all the subtrees. This is the tabular training set from the decision tree. We will get this training set from the previous decision tree, and where this is the class, and the classes are just two types. There's yes or no, and these are the nodes. This is the combination of nodes and branch, where 81, 82 and 83 and 84 where A1, A2, A3 and A4 are belongs to, these are the branches. So where A1 is from 81 and A2 is from 82, and which is from the previous, where from this tree we can get this those table, where A1, A2 and A3, A1, A2 and A3 and A4 gives rise to yes. So this is the class we are going to get for this sequence, that is yes. And we have some no also, we can check it there, and where A1 and B2, B3, A1, B2 and B3 gives rise to no, and B4 is also given to 4 no. So so there are some no's, and where this decision trees gives to the future analysis by taking the present data, and these A1, B1 and A2 are the branches, which are the values of these nodes. Where the previous decision tree is of logical based algorithm, where there are two types of logical based algorithms. One is decision trees and the other one is rule based classifiers. Now it is the statistical learning algorithms, where it is mostly related to the probability concept of probability in mathematics, and it is of underlying statistical learning algorithm underlies the probability model, which provides a probability that an instance belongs in each class rather than simply a classification. In this, we got the naive Bayes classifier. Uh, Classifier, which is a type, which is of a, we got a naive Bayesian probability concept in mathematics, which is used over here for finding the classifier. This is Naive Bayes classifier. It's a very simple Bayesian network which are composed of directed acyclic graphs. Directed acyclic graphs are the graphs which don't have any cycles, such that it's not a graph, and it is a graph, but it does not have any cycles. The independency model is based on estimating the R value, where R equal to probability of I by X by probability of J by X equal to probability of I into probability of X by J by probability of J into probability of X by J, where this is from the Bayesian probability mathematics. This is a Bayesian network, where Bayesian network is a graphical model of probability relationship among a set of variables. The Bayesian network structure is a directed acyclic graph, since it is from the Naive Bayesian classifier, and nodes are in one-to-one correspondence with the futures of X. These nodes are in one-to-one correspondence with the future of X. The arcs represent the causal influence among the futures, while the lack of possible arcs in S encodes conditional independency. Moreover, the future of conditional independency from its non-descendant given in its parents given x3 if probability of x1 by x2 comma x3 equal to probability of x1 by x3 for possible value of x1 x2 x3 is where this probability of x2 is given as this node features of future probability of this future is 0.95, and probability of x3 where this link is probability of x3 by x2 equal to 0.95, and in case of not the x2, now where it is probability of x3 by x2, where in this probability the summation of two components should be equal to 1, so it is approximately 0.1, and same in this case where x4 by x2 probability comma where x1 is 0.95, and this is where x4 by x1 not x2 comma x1 is 0, and this is where x2 is 0, and this is the algorithm. This is the pseudocode for training Bayesian network, and for constructing this training Bayesian network. First, initialization of G Bayesian network containing empty Bayesian network G containing n nodes. First, initialize the G containing n nodes, which may be Bn with n nodes but no edges. Without any edges, evaluate the score of G. We need to evaluate the first scoring matrix, and G dash, where is G is the another Bayesian network variable, where we are first initializing this G to G dash, where it is also a Bayesian network containing n nodes. It is a loop with e equal to 1 to n do, and for repeating for each node we are using these two for loops, and it is if I dot j, then if there is no edge for check, we are going to checking this condition. If I dot j, then if there is no edge between the nodes I and j in G dash, then modify G dash by adding an edge between the nodes I and j in J dash such that I is a parent, where I is a parent and j a parent of j. If this condition is true and we are going to make I as parent and j as child. If resulting g dash is a directed acyclic graph, then we are going to proceed. If the scoring of g dash is greater than scoring of g, then g equal to g dash. Then we are swapping the a final directed acyclic graph with the g, and we are going to end all the if statements. And this is where if this condition is fails, it is g dash equal to g, and we are going to end all the for loops. And thank you everyone, that's all.